Start, sir.
Okay. Students, welcome to webinar classes to learn physics. This is MBA Prasad, Jl in Physics, Jl.Hasnaparthy. In the last class, we started a new lesson, that is laws of motion. In that lesson, particularly we concentrated about the Newton's laws of motion. Newton's first law statement is every body in a state of rest or in a uniform motion in a straight line, unless it is compelled by an external force to change its state. That is first law. And second law states that the rate of change of momentum is directly proportional to the force acting on it. That is Newton's second law. The Newton's third law says that to every action there is an opposite reaction. Action is equal to minus reaction. So these are the Newton's laws of three laws of motion. And now we will go for a very important topic in this lesson, that is law of conservation of linear momentum. As you know about the momentum, momentum is the product of mass and velocity. So what is the law of conservation of linear momentum? If no external force acts on the system, the total linear momentum of the system remains constant. There is no external force acts on the system. Consider the system. If you are not applying any force on it, the total linear momentum of the system remains constant. Or otherwise, for two or more bodies in an isolated system acting upon each other, their total momentum remains constant unless an external force is applied. Okay, for two or more bodies in an isolated system acting upon each other, their total momentum remains constant unless an external force is applied. Okay, just to observe the diagram here. There are two spheres, A and B, having masses m1 and m2. Their initial velocities are u1 and u2. Both are moving in a straight line. Suppose if the first one's velocity is greater than the second one velocity, that is u1 is greater than u2, both are interact to each other or collide to each other. There is a collision takes place in time t. So after collision, the spheres are traveling with the final velocities A as v1 and B as v2. So this is the diagram that shows. Okay, the two spheres A and B having masses m1 and m2 moving with initial velocities u1 and u2. After collision, their final velocities are v1 and v2. According to this law, says that here there is no external force is acting on it in the system. But the total momentum before collision, that is, what is the momentum of the first body m1, u1? What is the momentum of the second body, second sphere B, that is m2, u2? The total momentum gives m1, u1 plus m2, u2. This is equal to the momentum after collision, total momentum after collision. So what is the momentum of the first body after collision? m1, v1. And the momentum of the second body is m2, v2. What is the total? m1, v1 plus m2, v2. Here, the system is isolated. This law only holds good when no external force is acting on it. So within the system, it will done. That means according to this law, the before total momentum is equal to after total momentum. So this is says the law of conservation of linear momentum. Okay, you got it. Then so we'll go for proof. I already told you that there are two bodies A and B, masses m1 and m2 respectively. They are moving with velocities u1 and u2 in a straight line. They are moving with velocities u1 and u2. They are initial velocities. If u1 is greater than u2, what happens? They collide to each other in very small time, that is delta t seconds. After collision, their velocities are changed to u1 as v1 and u2 as v2. Okay, this is the diagram. Consider first body. This is first body. Momentum before collision is equal to m1 u1. Momentum before collision is equal to m1 u1. As you know, the momentum formula, mass into velocity. So now I am only strictly concentrated about the first body. The momentum before collision is equal to m1 u1. In this, similarly, the momentum after collision of the same body is m1 v1. What is the change of momentum? Means difference of these two momentums. That is m1 v1 minus m1 u1. Okay, this is what? Change in momentum. In what time? Very small time, that is delta t seconds. So within delta t seconds, the change in momentum is equal to m1 v1 minus m1 u1. Now, just to take the second law of motion, Newton's laws of motion. What second law of Newton's second law says? The force, the rate of change of momentum is directly proportional to the force acting on it. See here, the force exerted by the first body on second body is F1. The force exerted on first body on second body is F1. Therefore, according to Newton's second law, this F is directly proportional to the change in momentum, so that you can say take F1 is equal to m1 v1 minus m1 u1 by delta t. That means this formula comes due to the Newton's second law. For second body, sorry, mistake it is there. For second body B, momentum before collision m2 u2, momentum after collision m2 v2. Change in momentum is what? The difference of these two momenta, that is m2 v2 minus m2 u2. According to Newton's second law, the force exerted by the second body on first body, say it is F2. Therefore, F2 is directly proportional to, or F2 is equal to m2 v2 minus m2 u2 by delta t. So in this way, we got two formulas, F1 and F2. That is, first one exerted on the second body and second one exerted on the first body. Those are nothing but F1 and F2. According to Newton's second law, what it explains? Action is equal to minus reaction. To every action, there is an equal and opposite reaction. So that action is equal to minus reaction. So what is the action F1? First one exerted force on second one. What is the reaction? The second body exerted force on the first body. So that F1 is equal to minus F2. So F1 we already calculated, that is M1V1 minus M1U1 by delta T. Reaction, that is F2, M2V2 minus M2U2 by delta T minus is there. So cancel delta T. We have only M1V1 minus M1U1 is equal to minus of M2V2 minus M2U2. So take it minus inside the bracket and rearrange the terms. You can have M1U1 plus M2U2 is equal to M1V1 plus M2V2. This is the thing. This is the law of conservation of linear momentum. That means the total momentum before collision is equal to the total momentum after collision. So then that means this linear conservation of linear momentum only holds good if no external force is acting on the system. Remember. So it is about the conservation of linear momentum. Okay, you got it. So the very important statement and derivation. Now we will take some examples, very interesting example about the law of conservation of momentum. You know that a bullet is fired from a gun. So bullet comes with a lot of force from the barrel. At the same time, the gun pulls backwards. That is nothing but recoil. You can say it's a recoil of the gun. Consider the example of the bullet fired from a gun. So it is the thing before thing. If the force exerted by the gun on the bullet is F, the force exerted by the gun on the bullet is F. The force of gun by the bullet is minus F. So both are equal and opposite. F is equal to minus F. Therefore, F plus F is equal to 0. That means the total momentum is nothing but 0, remains constant, or you can say. Now, see, just have a look, the explanation. A bullet of mass m1 is fired with a velocity v1. Actually, a gun is there, bullet is inside, having mass m1 with velocity v1. Gun of mass m2 and recoil with velocity of the gun is v2. Initially, you observe that both the gun and the mass and the bullet are in the rest position. Means their initial velocities u1 and u2 are 0. You already know the statement of conservation of momentum. m1 u1 plus m2 is equal to m1 v1 plus m2 v2. Just remember that whole formula, and here try to understand the terms. Initially, the gun is at the rest, means its initial velocity is 0. Likewise, the bullet is also inside the gun, means it has initial velocity 0. If the bullet is fired with a velocity v1 from a gun, that means whenever you fire the gun, the bullet comes with a velocity v1. And at the same time, with a large force it comes out from the barrel, there is a force exerted on the gun then it is recoil, means it pulls backwards. That is called recoil of the gun. So then recoil of the gun is equal to V2. Now, the total momentum before firing is equal to the total momentum after firing. It is the important thing. As you know the formula, M1U1 plus M2U2 is equal to M1V1 plus M2V2. But here, U1 and U2 are 0. Why? Because the gun is at the rest, means its initial velocity is 0. Bullet is at the rest, its initial velocity is 0. So that the total, this term turned to 0. So 0 is equal to M1 plus M1V1 plus M2V2. Therefore, M1V1 is equal to minus M2V2. This negative sign indicates momentum of bullet is opposite to the momentum of the gun. So both are opposite to each other. Here see the diagram. Bullet is coming in this direction. The recoil of the gun is in this direction. So both are opposite to each other. But the total thing is 0. That is nothing but law of conservation of linear momentum. Here, see, actually there is no external forces acting on it. The bullet, the substance of the bullet fires abruptly. Of course, it comes out with a lot of velocity from the barrel. Here, there is no external forces acting on it. Remember. So that is why. So this is the best example of law of conservation of momentum. And just you know that motion of the rocket. When a rocket fires, the fuel burns, releasing the exhaust gases downwards, pushing the rocket upwards. It's very important thing. How the rocket fires and how it moves. Simply you can say because of the Newton's third law is the main thing to move the rocket. At the same time, there is another law of conservation of momentum also present in it. When a rocket fires, whenever the rocket fires, what happens? The fuel burns, releasing the exhaust gases downwards, pushing the rocket upwards with equal and opposite momentum, so that the rocket moves upwards. Okay, so whenever the exhaust gases are releasing from the barrel with a lot of force, so that the rocket moves upwards. So in this way, it is also the motion of the rocket also involves the law of linear conservation of momentum. The same similarly, motion of jet plane also. These are the best examples of law of conservation of linear momentum. Okay. So next one is very important physical quantity, friction. Friction. So what is the friction? When it holds good, what are the types of friction and their explanations? Now we'll study those things now. The force which opposes the relative motion between two surfaces which are in contact, very important, which are in contact is called frictional force or friction. When the body is moving on the other body, there is a force acting opposite to it, opposite to the motion of the body. That force is called frictional force. Simply we can say it is a friction. it is always parallel to the surface. Friction is always parallel to the surface. Next one, it acts in a direction opposite to the direction of the motion of the body. Yes, the motion is in one direction, friction is in opposite direction. Frictional forces also exists when one body is rest over the surface of the other body. Yes, it is only it will exist when two bodies are in contact. They should have relative motion. So one body, a body is moving on the other body means there is a friction exists between these two surfaces. The friction is a resistive force, or you can say it always opposes the motion of the body. That is called friction. So once again, just I am repeating the statement and its explanation. The force which opposes the relative motion between two surfaces which are in contact is called friction force or friction. So these are the things should remember. It always parallel to the surface. It acts in the direction opposite to the direction of the motion of the body, and it exists when one body is rest over the surface of the other body. Okay. Now we will study about the advantages and disadvantages of friction. So very important to know these things because these are very useful in our daily life situations. Now we'll take advantages of friction. What are the advantages? Everything. Without friction, we cannot do anything. Without friction, we cannot run our normal life. Some of them just we can study now. One can hold any object with fingers due to friction. Suppose if you hold a pen or pencil, there should be a friction exists between the finger and the pen. Then only you can hold it. So if there is no friction, you cannot hold the pen or pencil or anything. One can walk safely without slipping because of friction between ground and feet. You are walking, running, so everything due to friction between the feet and the floor. If there is no friction, what happens? You simply skid or slipping. So one can walk safely without slipping because of friction between ground and feet. A matchstick is lightened because of friction. Suppose if you lighting the matchstick, so then what you do because of the rubbing with the stick, it will lighting. A matchstick is lighting because of friction. Nails and screws are driven in the walls. Suppose if you drive the nails, there should be friction present between the wall and the nail, so that so nails and frictions are driven in the walls. These are only some examples. There are so many in our daily life situations. Now, what are the disadvantages? Due to friction, wear and tear of machines increases. Yes, because of friction, there are inner parts are there. So because of the movement of the inner parts, because of the friction, so then there will be wear and tear takes place. That is a lot of loss of vision. Heat generated due to the friction decreases the efficiency of engine. So because of the contact between the two wheels or in the machine, there will be heat generated. So because of that, the efficiency of the engine decreases. Friction results in the large amount of power loss in the engines. Of course, these are all the disadvantages of the friction. Here, students, I mentioned very few things. There are so many things which are comes in the under category of disadvantages of the friction. Now, we'll go for another thing, that is types of friction. Types of friction. Friction is of three types: static friction, kinetic friction, and rolling friction. Okay, friction is three types: static friction, kinetic friction, and rolling friction. Now, we will study about the static friction, and then kinetic friction, and then rolling friction, one by one. Try to understand the definitions and their meanings. What is static friction? So static friction means it is a frictional force present between two surfaces when one body rests over the surface of another body is called static friction. You already know about the friction. Friction only takes place when the two bodies are in contact. So one body is moving on one surface, so then only friction takes place. If it is a parallel, it is acting always parallel. It is an opposite force. You know all these things. Now try to understand about the static friction. Suppose a box is on the floor. You are trying to pulling or push the box. At first you apply the force. It will not move. Means what? So your force is compensated by the frictional force. There is a force, there is a frictional force exists between the bottom surface and the floor. It opposes. That means although you are applying force on the box, it will not move, means so your force is compensated by the frictional force. If you are increasing the force further, what happens? The frictional force also increases. It won't move. Still you are increasing your force on the box, then it will move. Means the frictional force, your force is crosses the or more than the frictional force, then only it will move. Up to now, that friction is called static friction. Okay, try to understand this. I think again I am repeating this. Static friction. There is a box on the floor. You are trying to pushing the box on the floor. You apply force on it. Although you are applying force, but box is not moving, means your force is not enough to move the box. That means there is the frictional force is of course is more than your force. By increasing the force on the box still further and further, then the box will move, means your force is more than the frictional force existing between the two surfaces. So that force is nothing but that is the static friction. The maximum value of static friction is called limiting force. Very important. Suppose stretch your palm and then you place weight on your palm. You can hold it. Suppose 1 kg weight, you can hold it, no problem. That means weight is comes downwards, and of course you are trying to lift it and increase the weight on your arm, so that although the weight increases, you are trying to hold it. Still you are increasing the weight on your palm. What happened? So you are not in the position to hold it. That means your limit crosses. Similarly, after the maximum value of static friction is called limiting force. So that if it crosses limiting force, what happens? The box will move. So that is about the static friction. Okay, next. Second one is kinetic friction. What is kinetic friction? The frictional force present between two surfaces when they are in relative motion, is called kinetic friction. See, what is the difference between these two? When one body is rest over the surface of another body, that is static friction. When there is a relative motion, there is a frictional force exists between the two surfaces, that is called kinetic friction. That means suppose you are pushing the box on the table on the floor. So you are applying force on the box. By applying the force further and further on the box, at one instant the box will move. That means that is called the static friction. So whenever the box move, you can easily move it on the surface. That is nothing but kinetic friction. That means when the one body is moving on the other body, there is a friction exists between them. That friction is called kinetic friction. Here, if you compare between the static friction and kinetic friction, the static friction is more than the kinetic friction. Yes. So whenever the body starts on the surface, it can easily move. No need to give that much of force because of the less frictional force. So that less frictional force, when the body is moving on the surface, so that is nothing but kinetic friction. When you compare the magnitude of these two frictions, the static friction is more than the kinetic friction. Third one is rolling friction. What is rolling friction? The frictional force between two surfaces when one body rolls over the surface of another. When one body rolls over the surface of another body is called rolling friction, that you can say Fr. Compare these three frictions. Static friction is greater than kinetic friction, is greater than rolling friction. That means rolling friction is very less compared to these two. When one body is rolling on the other surface, on this one of the surfaces, so that suppose that friction between them is very less. So that is why it simply go forward. So in this way, we'll explain the study about the types of friction. How many types of frictions? There are three types of frictions. Static friction, that is when two surfaces, when one body rests over the surface of another body, the friction exists between them. That is called static friction. So the maximum friction is nothing but limiting friction. If this limiting friction crosses, what happens? The body starts to move. Whenever the body is moving on the other surface, so that The friction between these two surfaces gives the kinetic friction. That is why it is between two surfaces when they are in relative motion. Very important. Very relative motion. When one body is sliding on the other side or the other body, there is a friction exists that is called kinetic friction. Compared to these two, that Fs is greater than Fk. That is static friction is greater than kinetic friction. So what is rolling friction? When one body rolls over the surface of another body, there will be friction exist between them. That friction is called rolling friction. That is called Fr. It is very, this value is very less compared to about 2. The relation between these three is Fs is greater than Fk is greater than Fr. So this is the relation between these three. What is angle of friction? Okay. Now we'll discuss about the angle of friction. So before going to the definition, try to understand the diagram here. Here, it is a surface. I put a box on it. Here, I place a box on it. As you know that the weight of the box is downwards. It always downwards. It pushes the surface. At the same time, the surface exert force on the body or box. What is the thing here? That is normal to it. That is called normal force. Here, mg is weight of the box acting downwards, and here n is the normal force acting upwards. What is the normal force? It is the force which is acting perpendicularly upwards from the surface. That is called normal force. Okay, this is a normal force and it is weight. So both are equal and opposite. So whenever these two are equal, then the box or body said to be rest on the surface. Here, another important term you should learn, that is about the normal force. It is the force acting upwards from the surface. That is called normal force. Here, just try to observe the diagram. Mg is acting up downward. Here, just I keep a block on the surface. Mg is acting up downwards, its weight, and its normal force is acting upwards. Here there is a frictional force acting in this direction. That is limiting friction. It's a maximum friction it is. So what is the normal force is acting in this is perpendicular up, and frictional force is acting horizontal. So that here there is a resultant force. If you resolve these two components, it is a resultant force R. This is R. You already studied in our previous classes, that is the resolution of vectors. Here, this is the resultant vector. This is the resultant force. Okay. Again, I am just trying to understand this, to understand to you people about the diagram. A block is placed on the surface. Although I am applying force on it, it will not move. Means what? The force is equal to the limiting friction. There is a force acting upwards, that is normal force. The resultant force is like this. The angle between the resultant force, that is R, and normal gives the angle of friction. Angle of friction. It always gives theta. Theta. We can represent it by the letter theta. So theta is the angle of friction. So one can ask you, sir, why don't you take this angle? That is from F1 R. F1 R. I'll explain you why. Because that means if we increase the friction, what happens? The R also, the resultant vector, the slope increases. That means theta is also increases. That means theta depends upon only on the friction. So that is why you can take this angle instead of this angle. You got it? So that you can say what is the angle of friction? It is the angle between the normal force and the resultant force. That is nothing but angle of friction represented by the letter theta. Now just make a parallelogram like this. Here AOC is the right angle triangle. It is theta. It is opposite side and it is adjacent side. It is hypotenuse R. Now just you take mathematical derivation cos theta. What is cos theta? Adjacent side by hypotenuse. So what is adjacent side? It is n. And hypotenuse is r. That is cos theta is equal to n by r. Cos theta is equal to n by r. From this, n is equal to r cos theta. It represents equation number 1. Similarly, consider sin theta. Sin theta is equal to, here this value is equal to this value. That means sin theta is equal to fs by r. Fs by r. Therefore, that is static friction. Fs is equal to what? R sin theta. Fs is equal to r sin theta. Have a look. Just these two equations. It is equation number 1 and 2. So take equation 2 by 1. 2 by 1. That is sin theta by cos theta and fs by r whole by n by r. Fs by r whole by n by r. You know the sin theta cos theta is equal to tan theta is equal to r cancel fs by n. Fs by n. This fs by n is equal to mu. This is coefficient of friction. This is called mu s, means coefficient of static friction. This mu is a constant. You can say it's a coefficient of static friction. Therefore, tan theta is equal to mu s. Tan theta is equal to mu s. Finally, theta is equal to tan inverse mu s. In this way, you can calculate the angle of friction. You can calculate the angle of friction. Okay. What is the angle of friction? Again, I am telling it is the angle between the normal force and the resultant force, theta. This theta is depending upon the friction. So that is why you consider this angle only, but not this angle. I already told you. When you increase that, if the friction increases, theta also increases. If that means this is increases, theta also increases. So that you choose only this angle. So finally, tan theta is equal to mu s. This is the letter mu, suffix x. Tan theta is equal to mu s. That is coefficient of friction, static friction, you can say. This is about angle of friction. Next, angle of repose. What is the angle of repose? It is the minimum angle of inclined plane for which the body tends to move or ready to move is called angle of friction. The minimum angle is inclined plane at which the body tends to move or ready to move is called angle of repose. Just see the diagram. Try to understand here. Here I put a block here. It's a block. It's an inclined plane. It is an inclined plane. I put a block here. Here it is an angle theta, that is called angle of friction. Suppose if you increase the angle, what happens at a certain angle, the body tends to move on inclined plane downwards. The angle at which the body tends to move or ready to move is called the angle of repose. Okay. Here the body is not moving. That is theta. If we increase the angle, what happens? The block is ready to move. The angle at which the body is ready to move, that angle represents the angle of repose. Write it. Got it. Now we'll go through it. Consider of a body mass m is placed on a rough inclined surface. It's a body which is having mass m is placed on rough inclined plane. Now you know that theta is the angle of friction. Now there are two forces acting on the body. There are two forces acting on the body. Here mg is acting downwards like this. It is mg is acting downwards because it's weight. If you resolve into two components by applying trigonometry functions, mg cos theta, which is perpendicular surface, and mg sin theta, which is parallel to this plane inclined surface. See, mg is the weight acting downwards. If you take this is the resultant vector, or you can say, if you take the components, two components, so one is perpendicular to the plane. This is inclined plane. And another one is parallel to the inclined plane. So this is mg cos theta. This represents the force on vertical side. It is mg sin theta. This is a force acting on the parallel to the plane, inclined plane. Now, when the body is rest here, when the body is rest, means these two forces are equal. That is what happened. N is equal to mg cos theta. This is the force which is acting opposite to the frictional force, that is F is equal to mg sin theta. F is equal to mg sin theta and N is equal to mg cos theta. Both are equal. They are both forces are in opposite directions, so that their magnitudes are same. N is equal to mg cos theta and F is equal to mg sin theta. When it is, then the body is rest on the inclined plane. If theta is equal to alpha, means what? Suppose if the inclination plane, this theta increases, what happens? The slope increases like this. At that time, the body tends to move. Therefore, Fk, that is kinetic friction, exists between these two surfaces. When the body is in the motion, what type of friction exists? Kinetic friction. If the body is in the rest on surface, what is it? What type of friction it is? Static friction. Remember this thing. Here, that's why I take Fk. Fk is equal to, instead of theta, here I wrote alpha. Why? Because it is tends to move. It tends to move. So Fk is equal to mg sin alpha. Similarly, n is equal to mg cos alpha. From the laws of friction, as you know that friction is directly proportional to the normal reaction, so that if you take the proportional to constant, Fk is equal to mu kn. That is, what is mu k? It is coefficient of kinetic friction. Coefficient of kinetic friction. So what is Fk? Mg sin alpha. This is mg sin alpha. What is n here? Mg cos alpha.